Good morning and welcome everyone. Thank you for joining us at e-KLESF 2022. I'm Dr. Ong Keju from University Abdul Rahman Utah. Today, Dr. Ching Tat Tu will be presenting a webinar titled My 15-Year Journey of Chemistry Research. Dr. Tu is an assistant professor at the Department of Chemistry, Dong Hai University, Taiwan. Just a little housekeeping before we start. If you have any questions, please type them in the chat box. We will bring them up during the Q&A session at the end of this webinar. Dear participants, please sign your attendance in the link posted in the chat box. Without further delay, let us turn the time over to Dr. Tu. Dr. Tu, over to you.
Okay, thank you very much. So I shall share my PowerPoint first. You see the screen. So can you see the PowerPoint screen?
Yes, we are able to see your screen.
Okay. Because this is my first time to use the Zoom actually. Okay. Okay. Good morning, everyone. I'm Ching Tat Tu from Taiwan. My title is my 15-year journey of chemistry research. But actually, I'm trying not to give you too much details on my own research in the field of chemistry or some of the frontier science. But more, I would like to share my personal experience, actually starting from my bachelor study and then my PhD study, postdoc, and how I would like to become a principal investigator. Okay. So maybe I will try to finish my slide in about 40 minutes, and then I'm more than welcome to receive any comments, questions, or exchange of ideas. Okay. So actually, I come from Hong Kong, so I received most of my education in Hong Kong. I enrolled the Chinese University of Hong Kong Department of Chemistry in 2007. So starting from that year and until now, so that's exactly 15 years. And then I continue to pursue my PhD study there, and I successfully received the degree after 5 years. Then I moved to Japan to join the e-KLESF. Actually, that is a research institute rather than a university to do my postdoctoral work. I stayed there for 3 years, and after that, I have 1 year returned to Hong Kong. And finally, I have established my independent career at Taiwan, Dong Hai University, which is located in Taichung. Okay. So actually, my research group is still very young. Now is my 4th year of independent career. Okay. So I would like to share with you my undergraduate study, how you should prepare or how you should not enroll or to continue further study in a PhD program, what you should do or what you can learn in a PhD study, and actually what a PhD means, particularly nowadays with a fast changing world. And finally, I will share some of my personal experience after becoming a PI, the difficulties you may face, or what kind of joyful moment you can obtain. Okay, so I hope we can share, or if you are trying to thinking whether you should pursue a PhD study, or you are similar to me that you are also a young PI, so I think we may exchange some more experience out in the QA section. Some basics information in my years. So At that time, my class in the CUHK, about 60 undergraduate students, local students. So in my class, only about 10, including me, so it comes up 11, pursue the PhD study. But actually, we have some many other foreign students also joining the PhD program, but this is only for the local London, so for the Hong Kong people at that time. Unfortunately, two of them decide to quit in the middle of the PhD program for their own reasons, or some will drop out as an MPhil to end the study earlier. Okay. In these 11 students, okay, most enter the chemistry-related industry. For example, some pharmaceutical company, or high school teaching, or some other research facility. One of my friends went to totally unrelated industry, okay? And me is one of the example that continue to pursue in the academia. So actually, pursuing a PhD means that you would like to further work on that discipline. So for me, it's chemistry. So if you really like the subject, it is the first criteria that you're probably suitable to pursue a PhD program. And the first step for a PhD begins at the undergraduate period. Okay. You can decide to join a group as early as possible, such that you can experience what is research, how your senior member or other postdoc doing research in a particular group. So this is a photo taken back in 2008. Okay, my supervisors here on the left. Okay. It is a medium-sized group. So at that time, I tried to avoid a large research group as well as a very small research group. So I decided a medium-sized research group. So that is me. I'm still an undergraduate that time, year 2, and I joined the group during the summer of at the end of the year 1, such that I can experience how a research group is running, or do I really like the life of staying in the lab. So if you are planning some further study in a doctoral program, postgraduate, try to join a group as early as possible. So if you don't like the lab life or some kind of research life, so you may decide to go to the industry right after your undergraduate study. Many people think that pursuing PhD study requires a very excellent academic results. I would say that is a yes and no as well. Okay. For the yes part, it really helped you to understand some of the very difficult subjects. But for the no part, okay, a PhD program takes probably at least 4 years. In that 4 years, you can improve yourself. Okay. For example, I take my personal experience as example. In my research group, in this group, 2/3 of them are first honor graduate. So that means they are in the top tiers, but sorry, slide is not working. Okay. So this is my transcript at that time. So I always show my transcript to my student during my class. So my grades, some is actually in the middle in terms of this university. So I only somehow middle, but you can see that my grades are getting somehow better, particularly in the later year of my study. Okay, so improvement indeed takes time. So it is not like that you read the book today and you can immediately get a good result tomorrow. So it takes years to improve. Okay. And I believe this is also why a doctoral program takes at least 4 years, and some may take 5 or 6 years to collect some meaningful results. This is all about the effective learning. It is independent of the subjects, whether you're chemistry, physics, biology, or engineering. Okay. There are several important points you have to know or you have to work on every day. Okay. All the lecture notes provided by your lecturer, professors, or teachers, they are all only basic materials. Okay, I would say those materials only contain probably 10 to 20% content from a textbook or reference book. Okay. So every time after each lecture, you should read the related chapters in the textbook. Okay. So how many times you should read? How often you should read the textbook or reference book? So I showed some of my book back in my age. So you can see the binder or the side of the book is somehow getting yellow in the middle part of the book, because you have to take the book, open the book with your finger. So it is not 1 time, 2 times, or just before the exam. So just read the book regularly, constantly, every day. So you get a very solid understanding of the materials inside the book. So preview all the materials before the class, so you will briefly understand what kind of question you are going to face in the class, and review all the materials after that. Okay. And very importantly, you should ask questions. Ask questions to the lecturer or discussions among your classmates. So all the fruitful ideas or improvement comes from discussion, asking and answering questions. So this is how I prepare for my PhD study during my undergraduate period. So when it comes to the PhD study, okay, it takes a minimum of 4 to 5 years. So what will you learn from this program? So I try to summarize a few points that I think is very important. Okay. As a science and engineer field PhD program, so you are going to do a lot of experiment every day, okay, repeatedly. Okay. So you build a very hardcore skill. That is a hard skill based on your practical skills, or how you run the experiment. You have to ensure the reproducibility of everything. And I would say this is the first impression to your supervisor, that he trusts you, or to gain trustfulness from your supervisor. But this does not mean that you need some publishable data as soon as possible, but you have to show them you can able to perform experiment by yourself. So it is more like during the first EAT, okay, you have to get familiar with all the basic techniques. This is a hard skill. And the second is more on the soft skill. So in science and engineering, so you need a logical sense of argument. So we observe something, so we propose a theory, you decide the experiment to prove it or disprove it, and then you make the conclusion, so whether your proposal is correct or not. And then you rerun the whole process again in the field of your research. So you have to, so you will develop the logical sense of argument, either in the form of a presentation, in the form of writing, as well as the design of experiment. Okay. The third one, and I feel that this is quite important, particularly during my PhD study, is to pay attention to every details. Okay, every experimental details, all the data you collect. If we talk about like this WKID pyramid, okay, so all kind of wisdom or theory or your knowledge are based on facts. These facts are information that may be public through the Google, through the journal papers, through other people's research, and also from data. But the data, that means your experimental data during your PhD study. And you are the first hand who collect the data. So you have to be very responsible for your data. I remember one time that I struggled with my supervisor on the identification of an unknown chemical compound. Okay. So I proposed something different from my supervisor's idea. Okay. So if you go back to this triangle, so without doubt, or in most cases, your supervisor must have much more wisdom than you, that he or she may more likely to be correct. But you are the one that collect your experimental data. Okay. In principle, you should know the data very well. So you have to pay attention to every details. For example, in chemistry research, we run some NMR, nuclear magnetic resonance, of an unknown compound, such that you may elucidate the structure of that compound. Okay. So you have to pay attention not only the major peaks, but also to some very minor peaks that almost you would like to omit that or just pass away. But they are critical, they may be critical for you to propose something that is really correct or not. Because your supervisor doesn't have time to go into every details, to every spectrum, every data, every numerical results of your experiment. So you have to persuade to your supervisor based on your data. This is why I would like to say that pay attention to every details. Okay. So in some cases, you are right, and your supervisor may be wrong. Okay, may be wrong. And I remember at that time I struggled with my supervisor for almost 5 or 6 months on the assignment of 2 compounds, and indeed finally, so my supervisor agreed with my proposal, and in that period, at that period, I remember that, so I have to think of every logical method to support my proposal. So I have to go back to the logical sense of argument. So you have to look in between these 2 periods all the times. Okay. So when you face some difficulty, I would say that is the best way to learn and the best way that you will learn the most. The 4th key point is that once you have all the hard skill, soft skill prepared, you begin to have some measurable research output, either in the form of the book chapter or in the form of journal articles, review article, or some public presentations. Okay. These research output are very critical for you to find the job later, either in the industry or in the academia. So all those measurable research output will appear in your CV. Okay. That is critical for your first job after you graduate from the school. Okay. So I always talk to my students that your CV is important. It's very important for you to find the first job. Okay. And a PhD study is a very long period of time. Whether you can continue or you can maintain the driving force for your study is a curiosity. Okay. Curiosity in your discipline, in chemistry, in physics, or in mathematics. It is the most important driving force for you to keep going on improving your hard skill, your practical, your experimental skill, go through all the details repeatedly and all the other scientific informations. So if you find that you gradually lose your curiosity in your subject, so I think you better take a break, rethink what a PhD means to you. Do you really need that? Or do you enjoy the process or else? Okay. It is because PhD study is just not a mastery of a discipline in your field, but it is also a training of the mind. In the past and now, a PhD means totally different things in my point of view, okay? Particularly in a fast-changing world like today. Okay? Now I feel that a PhD degree is more like a training of emotional intelligence rather than a hard skill in your research field. So why I would like to particularly draw out a timeline here, for example, from the early 1980s and until now. Because in every era, there are numerous important technological advancements that can affect your PhD study. Okay. I can slightly explain more on that. Starting from 1970s, so there are personal computers coming out. Okay. And after that period, so you can, after that period, the 1980s, the internationalism comes in. So that means researchers from one country is going to communicate with researchers in other countries. So you start to know what other countries doing. So either through the computer or through the network at that time. Okay. In the past, when you like to receive some very updated information, you have to read the journals. And the journal is not on the internet like nowadays. So you have to order the journal books from the publishing company. Okay. But after the PC and the internet, okay, you begin to know what other countries doing. Are they competitive or are they potential collaborators? So I think in that period, 1980s, that is the most important change for the people who are working in the research field. But at that time, the internet is still not mature in the 1980s. I would say until 10 years later, okay, the internet become commercialized. So everyone start to afford to pay for the internet. And that is very critical for a successful research. And I would say that is a revolution period because you begin to know in your research field how many people is doing on that as well. Okay. If you are working on a very similar research topic, okay, they may be your competitor. So you have to work very fast. Or alternatively, you may have to slightly shift your research field if you feel that you cannot perform much better. And 10 years later, 2000 year, it is all about the perseverance. Because the admission to PhD, the admission number into the PhD program increased, there are increasing number of PhD students. So whether you can outperform some other, so you need perseverance. Okay, you have to work very hard. You begin to have long working hour to repeatedly working on the same subject in order you may perform better than others. In my point of view, all the period before 2000 is somehow too competitive. Okay, but after that, I see some bright future, or I see there are more positive cooperation around all the researchers. Okay, and that's the year of communication. Okay. As I mentioned in my first page, all the productive ideas comes from discussion, asking questions, or talking with each other. So the positive use of the internet and also all like this kind of webinar or more and more academic conference around the world promote a sense of communication. Okay. Science improves through the communication because your idea is limited, okay, your knowledge is limited. When you share your research result with others, so you receive feedback. These feedback help you to improve and perform better in your research. In particular, through conference. So that I will later mention a bit more about attending conference, either as a PhD student or either as a principal investigator. So how about nowadays? So what does a PhD degree means nowadays, or what is the major aim from a PhD program nowadays. So now every day there are very many new informations or breaking news every day. And I would say in the near future, a PhD is an ability to adapt. It is a tool for facing the change in a positive manner. Okay, so this is why I say that PhD is getting more on the emotional intelligence rather than a hardcore intelligence in your discipline, in your subjects. Because now the world is changing too fast. Okay. You have to review all your idea or research pathway every day. So the ability to adapt the change is critical, particularly after you graduate and you go into the industry, okay, to maintain the competitiveness. Therefore, a PhD degree is not a guarantee of a good job, high salary, or highly prospective future, but it is more a personal ability to adapt the change. So I indeed would like to mention one point, that PhD is not a guarantee of high salary. This is many people's false thoughts. I remember that I have read a chart when I decided to do my PhD study. Okay, so what's a PhD worth? Okay. If we are talking about a salary, okay, it seems that in the Western part, in the Western countries, in Europe and the United States, the salary between a PhD holder or a non-PhD holder is actually similar. Okay. In Asia, it seems PhD is getting some higher salary, but I think now it's getting close. Okay, because the data is like 10 years ago, so most Asian countries still under development. So we need PhD at that time, but it seems that we are now getting too many PhD. So remember that a PhD is not a guarantee for high salary, but it is more on the emotional intelligence, how you face the problem, how you get some solution to the problem, some difficulties. So this is what I learned from my PhD studies and how I look back what a PhD degree means to me. And very luckily, I'm one of the members that I to continue into the academia. And after becoming a PI, I faced many problems. And indeed, all the things I've learned during my PhD program helped me come through all the difficulties. So after becoming a young PI, the first thing you are going to face is a teaching load and all kinds of administration work. At the same time, you are also struggling about your research fund and or your own research. But please remember, your salary every month mainly comes from your teaching. Okay. The undergraduate student or the school fee is the main source of your salary. So please do the teaching well and perform all the admin work. Okay. And very importantly, try to make your own lecture notes. Okay. Avoid using the lecture note provided by the publisher. Okay. Nowadays, the students are very smart. Okay. They will comment on how your lecture notes made, whether it is beautiful, easy to read, or whatever else. Okay. That is the way to build up your reputation within the students. Okay, so you need a good reputation within the students, so that may help you to recruit some group member for your research. Okay, so try to make your own lecture notes and tailor-made that suit the department's use. Okay. It would be very time-consuming for making your own lecture notes, but only in the first few years. So after that, so you just make slightly update that according with every year's news, you can put some updated information. So second is a research fund or writing your research proposal. Without any money, you can do nothing. But at the same time, you have to spend the research fund wisely, because research fund is always competitive, no matter whether you are in Hong Kong, in Taiwan, in Malaysia, or in Europe or in America. So you have to pay attention to all the details of your proposal, avoid all the careless mistakes. No one will guarantee whether your proposal will work or not, but you can avoid all the careless mistakes in your proposal. Okay. So once you get the funding, so you can buy the stuff or all the instrument, all the consumable for your research. So plan all the budget carefully. So whether that instrument is necessary or not, or plan your priority, whether they should be bought first or later. Okay. Because that will limit or that will affect how you plan all the research later on. Okay. I heard many stories that other young PIs, they buy too much that is later not helpful to their research, and a lot of money is wasted. Okay. So you have to plan all the budget, and as a first-time PI, so you may not know, or how do you know how many budgets you need? So that date back to your PhD studies. Okay. So at that time, you should begin to learn the price of every instrument, every chemicals, how much money is spent per month in your research group. So you will have an idea what amount of budget you are going to request in your research fund, or how much money you are going to spend in your group, and you have to control or maintain the budget. And the third one is to your group member, and particularly some of your first few research group members. So I would say recruit, because you can select A PI can select your own students, and I also tell my students or all the potential group members that you can also pick your desired supervisor. Okay. Your first field member is very critical for your initial success in terms of your research. So if a very honest comment, if you feel that the student is that going to join your group is not suitable, so just reject them. Just reject them. Okay. Because again, I have heard some story from my friends or from my colleagues that they are having some student after joining the group, so they are doing nothing in the group, so that impart very negative impact to other group members. So it will bring negative impact. So it is better to refuse them before they are joining. Okay. So very luckily, my first two group members are very productive. So they have helped me to complete some of my initial project, and the result is successfully published 2 years later. So it's published in 2021. So I put their name as a co-first author in one of the journals. So they're also very happy that their result is published in an internationally renowned journal. And as a young PI, okay, try to do the experiment by yourself as well. But that is the only way to obtain publishable data as soon as possible. And that is also very critical to secure your research fund later on. And doing the experiment by yourself at the same time provide very important driving force for your student. It is not the way to monitor whether what time the student come to the lab or when they leave, but you act as a role model for them how to do the experiment correctly, and they will at the same time learn from you how to perform all the experimental skill correctly. And the final point, okay, the final point is maintain a good standard. Okay, provide SOP to your group members because it is a long-term career as a principal investigator. Okay. So again, avoid the menu, operation menu from the company. So try to write your own protocol or the protocol that is in your style. Okay. So every time when results comes out from your student, so you will know that whether it is correctly operated or not. So finally, I would like to share some of my idea or that may helpful if you are pursuing your PhD study or some kind of research project. It is the idea of addition and subtraction. In this photo, you see the development of portable cell phone. Okay, from the very early day to nowadays, the iPhone. You can see that there are addition of many functions, safety, ergonomic design, or readability. So these are addition or a plus. And at the same time, we are reducing the weight of the phone, so that is more portable. At the same time, you're reducing the size of all the components. So you are, for example, reducing the size of an antenna, so it is hide inside the cell phone case, not protruding out, and also reducing the number of parts. So now we don't have the button. Okay, so we don't have the button. We only have a touchable screen. Okay. So when it transforms to the idea in doing research, again, so you follow the rules of addition and subtraction. Okay. Can you give the introduction of research work from various perspectives? Okay. Not only from one perspective, but various perspectives, such that you can persuade potential audience from different backgrounds. Try to provide as much scientific evidence as possible that is a solid support to your proposal, to your ideas. Okay. And try to come up with a solution that can hit two birds with one stone. Okay. So that means at the same time, you try to reduce the amount of redundant experiment you have to perform, because redundant experiment meaning the waste of research fund. So you are spending money on some meaningful experiment. If you can run the reaction, this is more particularly in the field of chemistry or maybe physics, in a small scale, try to keep it small. Okay. Because that will reduce the complexity of the system. Okay. So that is the meaning of addition and subtraction that all the way help me to do the research. So, okay. And then is to get the exposure. Okay. Try to attend conference every year. Okay. Attend conference every year, either in the form of oral or poster is fine. During the conference, you can make friends. So, and particularly, I would like to make friends of my age and from different academic backgrounds. Sometimes you will have very intense discussion among your age on some topics. So when it comes, so you will grab everything that you can discuss. So we will write it on a leaflet of some kind. I cannot recall exactly. I think it's a menu from a restaurant. So we write all our ideas, because we come from a different background or different expertise. So we share our understanding, and finally we come up with something meaningful or that will be helpful to every other's research. And finally, it's all about the publications. Try to treasure all kinds of research work, regardless of the journal impact factor that's now getting somehow obsessed nowadays about high impact factor journals. Discovery can be a random process. Okay, some discovery can be very important. Some can be a small step in your research, but all of them count. Okay, all of them count. So try not to bother all the times to publish in a high impact factor journal. And try to treasure all the works of your group members. Okay, and select a suitable journal to publish your results. Okay. I think time is almost up. So I would like to take the last few minutes to introduce our department. So please visit this website later. So chem.tsu.edu.tw. So our department is very mature, containing 17 PIs now, covering the field of organic chemistry, inorganic chemistry, physical, analytical, and biochemistry. Okay, some of them are very experienced, and we have a good distribution of age. So we have 4 very young PI, including me. If you visit Taiwan or visit Taichung, so please drop me an email so I can lead you around or introduce the facility of our department. So finally, okay, it's about my research group. So my research interest is in the field of organometallic chemistry. In case you like organometallic chemistry, so drop me an email. So this is the website of my group. Okay, it contains all the publications, my research interests, or all the works from my students. So it is quite interesting that nowadays they are getting more female students to study chemistry. So in my age, so there's almost male students. Okay, I think I should. That's all for my talk today. So I would more like to receive comments, questions, or experience of your own personal experience. Okay, so thank you very much.
Thank you, Dr. To. Now we will go ahead and take some time for questions. Just a reminder, please type your questions in the chat box. Okay.
So I think
Dr. To, I think there are 2 questions in the chat box.
I think it's from Vincent Lim. Okay, the first question is memory an important skill for PhD study? How does one remember the various complex chemical formulas? Memory comes from short-term and long-terms. So if you read the books or read the journal papers or read the related information every day or every week, so I believe it will become your long-term memory. So it is only a matter of time. Okay, so my idea or my suggestion is that a good reading habit is not reading one time, but reading it repeatedly multiple times. Okay, my habit is that every week I will pick the paper that I will read at least 10 times. That is helpful for my research or highly related to my research or helpful for my future ideas. Okay. So I would say memory is indeed an important skill, but that skill can be trained, So not to worry if you cannot memorize too much things. The second question is, can a research topic or area be outdated because it might take too long to reach the findings or result? There are always some hot area of research that may be needed by, for example, the Nobel Prize of that year, or needed by some company, or some research company, pharmaceutical companies, or some technological companies. But I would say no research is outdated. If you read the word research, so you can divide it into the read, R-E, and search. Okay. There are always something that you can take out to redo. Okay. A research work that is almost done in the year of 1960. At that time, by the technology of that time, they observed something. But for example, after 50 years nowadays, you may have a much state-of-the-art instrument. So you may find out some interesting or something, some observation that at that time they cannot observe. So from that point, you may find out something that that may be different at that time, the conclusion. Okay. So I think research evolve with time. With more new instrument, you will find some new information, even from an old topic of research. So thank you, Mr. Lim.
Thank you, Dr. To, and thank you the questions. Okay, dear participants, kindly fill up the sign up form and feedback form after the webinar. Now we would like to take a group photos with everyone in this webinar. Dear participants, please turn on your camera and stand by. Okay, so everyone ready? 3, 2, 1, smile. Okay, let's take a freestyle. 3, 2, 1, smile. Okay, Dr. Tan, is there anything that you would like to cover before we wrap up?
No, thank you very much.
Okay, thank you, Dr. To, for the insightful webinar. Dear participants, please join us for the webinar titled Updates on Injury in Sports at 12 p.m. today. Thank you, everyone, and stay safe.